So projectile motion is the motion that an object takes when it is otherwise thrown or projected through the air. So for example, let's say we're standing on the ground and we throw a ball up in the air and it kind of takes this path until it hits the ground. That's what projectile motion is. The important thing to understand about projectile motion is that we're going to be splitting things into both horizontal and vertical directions, and we're going to consider them independently. Okay. So we're going to have our horizontal and our vertical directions, and we're going to, even this path here is made up of a combination of horizontal and vertical motion. What we're going to do to solve these problems is we're going to treat the vertical motion, the up and down that it makes throughout this path, and the horizontal motion as two separate things. And it's that combination of those two separate things that give us this nice projectile path. So since we're going to be splitting this motion up into x and y directions, what we want to look at is our equations of motion. In our x direction, or our horizontal direction, there is no acceleration. There's nothing that is going to cause, in the horizontal direction of projectile motion, there's nothing that's going to cause this object to change its speed, to change its direction, or anything like that. So in the x direction, the key here is that there's no acceleration. Okay. So if we look at our equations of motion, right, we'd have v equals v naught plus acceleration, this time in the x direction, times time. Well, acceleration in the x direction is 0, so my velocity in the x direction is just equal to my initial velocity in the x direction, which means it is constant throughout the whole process. Okay. If we take our equation x equals x naught plus v naught in the x direction times time plus 1/2 acceleration in the x direction times time squared. Well, again, acceleration in the x direction is 0, so that disappears. And my equation of motion for the x direction is just x naught plus v naught xt. So it's like something that's traveling at a constant velocity. So those are kind of our two equations. The third equation that we would have with the v squared equals just boils down to this as well, so we end up getting the same thing there. In the y direction, okay, we do have acceleration in the y direction, and our acceleration in the y direction is equal to g, right? It's the acceleration due to gravity, which you'll plug in as negative 9.8 meters per second squared. So for our first equation, we get velocity in the y direction is going to be initial velocity in the y direction plus gt. Then for vy squared equals v naught y squared plus 2 times g, and this time we'll use our y minus y naught to indicate that it's the vertical component of our motion. And y equals y naught plus v naught in the y direction times time plus 1/2 gt squared. And so those are going to be our sort of equations of motion for the y direction. Pretty much exactly what we had before, just knowing that our acceleration is going to be g for most every application. In projectile motion, we're going to be using vectors a ton. For example, the start of a problem might say that we're going to throw something with a velocity of 30 meters per second, and we're going to throw it at an angle of, let's say, 30 degrees to the. So what we're going to have to do is split up our motion into two different components, where we're going to have our v naught in the x direction and our v naught in the y direction in order to do calculations. To do that, we're just going to use just simple trig, right? So v naught in the x is going to be my hypotenuse, 30 meters per second, times the cosine of my angle, so cosine 30 degrees, and that would get us v naught in the x. V naught in the y would be our hypotenuse, 30 meters per second, and since it's opposite of our angle, that's going to be sine of 30 degrees. Calculating those, you'd get your v naughts in the two different directions, and then you could go on to use your equations to solve for whatever you might need to. One thing you may notice about those equations, something that's very, very important. Let's take the two position equations, for example. Okay, so x equals x naught plus v naught in the x times time. And then over in our y direction, we might have y equals y naught plus v naught in the y direction times time plus 1/2 g, which is in the y direction, t squared. Notice the thing that these two have in common is time. And this time is not specific to a direction x or y. So a lot of times when solving a problem, it's really, really useful to know time. And when you know time, then you can go between and find out where things are and how fast they're going in each different direction at that specific time. So time is going to kind of be a key for you in solving these problems. Also, never forget that we're working with vectors here. So for example, if I want the velocity total at some point in time, that's a vector component of everything else, right? So that's going to be my v naught in the x squared, if we use Pythagorean Theorem. So remember, v in the x direction never changes, plus my v in the y direction squared at whatever point in time that happens to be. Right, so we have to remember that these are vector components, and so anytime we're asked for any total of anything, we have to add them together as vectors.